started?
Yes.
Okay. So you see here, this is actually, we are at a mine site. It's a kind of, like you can say that they have started to make an adit into this body. So you can say that it's a kind of, they're trying to make an adit into this body so that they could find out some mineralization. And here the mineralization, what we see is that peacock kind of mineral patch. You can see that patch over here. This peacock mineralization is actually bornite. You see this blue coloration, this blue stuff, this greenish stuff, and this greenish stuff is all malachite. So these are basically copper carbonates, right?
Yes.
While this bornite is a copper sulfide. Apart from these two minerals, we see hematization here. We see the formation of hematite and limonitization as well. So we see limonite and hematite in association with these copper carbonates and copper sulfides.
Yes, sir.
All these mineralization are basically, they are of secondary nature. It means that there were some primary minerals in the form of chalcopyrite predominantly, which was because of this faulting, this shearing kind of activities, those were remobilized because of the presence of water, and accordingly they were transformed to bornite and malachite, and accordingly those copper minerals were formed. As far as this hematite and limonite is concerned, it can form from two types of minerals. One possibility could be pyrite. We all know that with sulfide, pyrite is very common. Pyrite is FeS2. So it might have formed from the pyrite, whose oxidation took place, and accordingly the sulfurs got released and iron reacted with oxygen in the presence of water. So limonite was formed, and in absence of water, the hematite was formed. There could be another possibility that along this plane, this fault plane, the mafic minerals, which are the host rock, like which are belonging to the host rock. You see, this host rock is enriched in hornblende and this reddish appearance. You see this reddish stuff. This reddish stuff is very evident over here as well. You see here, this is basically garnet hornblendite, or it could be garnet pyroxenite as well.
Yes, sir.
Which belongs to the Kohistan Island arc. Okay, so they
Yes, sir.
belong to the Kohistan Island arc. So these are basically the host rock, and within, you know, within these rocks, the like the hornblende and pyroxene, they are mafic minerals. So their oxidation, their hydrolysis, and later on their oxidation of the iron, which was released from them because of hydrolysis, hydration, that was actually converted to this hematite. So that's it. We also see some kind of green stuff over here. So these green stuff, it's predominantly chlorite, and there could be some serpentine as well. So chlorite and serpentine have also been formed from this mafic, ultramafic lithology, right? Indication that this is a fault zone. We see this very much flat faceted surface, and we see a kind of like four scarps are actually there, like you see.
Yes,
that
sir.
actually steps like structures are there. So, and again there's a polishing of the surface. So that polishing, that's only because the movement has taken place along
Yes,
this
sir.
zone, right? So this kind of mineralization, this mineralization you see over here, it's a fault control mineralization. It's a fault control mineralization, and it's, you see here, it's not pervasive. We traveled all along the road, like we traveled through this lithology, this garnet, granulite, we observed hornblendites, we observed pyroxenites, and across this whole, I will say like 20-kilometer cut cross-section, we didn't observe pervasive mineralization. So it's actually on the way. We at some places we also observed some small patches of malachite.
Yes, sir.
You observed those, those were also on the surface of those garnet and pyroxene and hornblende rich rocks, so which again reflect that they were secondary mineralization, which might have been related to localized so faulting within this zone. And you know that Kohistan or this area is also close to the MMT,
Yes,
man mental thrust zone. So we know that along man mental thrust zone there have been splays, multiple splays of the rocks. Mean that's a region, it's quite wide zone whereby different rock beds
Yes, sir.
were climbed
Over
on
one
top
another.
of each other, and that's a full complete zone of several kilometers.
Yes, sir.
Even at places several tens of kilometers was formed. So there could be multiple fault zones, and along those multiple fault systems, such kind of mineralization is possible. And again, I'll say that this mineralization is it's not pervasive; it's localized,
Okay, sir.
right?
sir.
Localized to the faults.
Yes, sir.
Thank you.